Hello all, welcome back to our Aislyn Technologies YouTube channel. Today we're gonna see about identification of a person by multimodal approach for surveillance purpose using AI. This project is going to be a very interesting project because this project work with the faces of our person like ear, eyes, and then by walking style. It could recognize the person. Like I will explain the abstract so that you will have a good idea about this project. Our objective is the research aims to improve a person identification by using multimodal biometric approach. This means combining different types of biometric data to identify individuals more accurately. Here we use the data source from our surrounding peoples. Like I took facial images, ear images, and then gained patterns. Gained patterns nothing but it's a step of walking style. Yeah, it's a walking style. Now what I have did is in our project, I extract the frames from the videos and then proceed up further. Here I've tried with CNN models. I have separated convolution neural network are trained to recognize each type of biometric data, and the combined outputs are merged by fusion technology to produce a final identification. Okay, and then I'll explain you the problem statement now. Here, our problem state is about systems that uses only one type of biometric data, like face. Here, our challenge is like lightning changes and variability in data. What if what if the face like variability in the sense so that so that it couldn't work very effectively in the recognition pattern, so that we have took one step ahead other with this project. Like we have some major issues like we can reduce the accuracy and reliability of person identification. Here, the proposed system is the research proposes a system that combines facial, ear, and gain data using convolution neural network of each type of data. Here, a feature fusion is after processing each type of data separately with CNN, the results are compiled to improve overall accuracy and the robustness. This is what we aim for. What we aim for is to improve overall accuracy and the robustness. And then in this research, we have found that in pre-processing, mainly we focus on pre-processing stuff and the feature extraction, CNN, and evolution. In pre-processing, we will prepare the cleaning and the biometric data for better results. In future extraction, we will identify key features from each type of biometric data. Each type of biometric data is nothing but it's a face, ear, and gait. That's what we're working with. And in CNN model training, the trained model CNN to recognize the and classify the feature from the facial image, ear, and then gain patterns. In this project, our objectives are to ultimately improve the system's accuracy and reliability. That's what our major aim. These improving system accuracy and reliability, there are main segments to work to mainly focus on. Those are namely integration of multiple biometrics. That is nothing but each of these biometrics has its strength and limitations. So combining them can lead to improve overall recognition performance. For example, where the first is partially observed and system can rely on ear or gain feature for identification. One of these, and then improved recognition accuracy and reliability. Like by using multiple biometrics, the system aims to provide more accurate and reliable results in the real world scenario where lightning condition or occlusion, like example, someone wearing a hat or mask. That's what occlusions on it, and then may affect recognition. Using multimodal approach will help them mitigate such issues. And then and the other feature is feature fusion methods. It's nothing but a significant part of research is dedicated to investigate how to effectively combine the features extracted from face, ear, and gain and modalities. These involve the best way to fuse or combine the methods. And then along with this, I have added something like optimization of pre-processing and feature extraction. Different biometrics are require different pre-processing and feature extraction technique. The research focuses on optimizing these methods for face, ear, and gain recognition to ensure that system works effectively and efficiently and effectively for each modality. Along along with these CNN model development, these CNN model development are specifically designed for tasks like image recognition. The research aims to train CNN model for each biometric type, face, ear, and gait, tailoring these models to the unique characteristics of each biometric. And then lastly, we will evaluate the model like performance evaluation against unimodal systems. The multimodal systems will compare with traditional unimodal systems that rely on just one biometric, like a face, like example, face recognition only. In this, the goal is to demonstrate how the multimodal system outperforms unimodal systems, particularly in the term of scalability. Scalability, nothing but how well it works within the dataset goes. Efficiently and robustness in different conditions. Example, poor lighting or partial localization. Yeah, this is what our objective. Now I will show you our workflow so that you will have a good idea of about the project. Yeah, here is our workflow. First of all, we will use a data set in the form of facial image, ear images, and gain patterns. Based on these, we will after this we will do pre-processing step. In this pre-processing step, we will remove the noise detection, starting with the outliers in the images in the data set. Image enhancement is we will enhance the image. We could add some pixels in the image so that CNN recognition will generalize the patterns over and over again so that it could be very useful to detect to detect the person very well and we will get a more accuracy based on this image enhancement. Normalization used to normalize the data, whether any other outliers is there, those stuff should be worked here, normalization. And then after this, we will use this facial features and ear features and gain features to CNN model, to the CNN model. Here, feature is conducting. Here we'll concave the features and we will reduce the dimension reduction so that our model will not become more complex. It will be very normal only. After this, we will classify. We will use machine learning technique, softmax, so that our unit should be dropped so that our model become not more complex. It becomes easy to see. And then final is evaluation. Here we will do identify, we will take the model, what we have earned. Based on that model, we will predict the person. Yeah. Now I will show you the code so that you have good idea. It will show you the code. This is our data set. Yeah, this is our data set. Like these are the videos. For walking style, we have to this. These are walking style videos. And then these are here videos based on the person one. These are person one. And then the person one of his image. Likewise, we took here, and this again is a leg part. What we are took in those video capture from there. This leg part. Now I'll take you to the training code. Now I'll take you the training code so that you could see. Yeah, this is our training code. Our target is 5. Okay, and our path is here. Here, what I have done is here I have trained separately for everything. First, I have trained ear here. What ear is? You can see this in our ear data set. There are totally five targets. So I gave that ear data set and 5 targets. Meanwhile, in the same, you will do this for everything. Yeah, here you can see the guide, and here we can use convolution neural network, and we will at last we will save the ear model here, and then it is for guide to walking style, and we have saved the model. Along with that, you will save here. Likewise, in the face recognition also, you will save the model here. In all this, we have used CNN model. First, we use 64 layers. First, we use 64 layers, and then 34 layers. In this, feature will be extracted over and over again, so that the model will be learned more good. After this, your model will be saved outside like this. Can you just know? Our model will be saved outside here. And then in testing code, we could dump those model In testing code, we could dump this model. Yeah, here you can see the test code now. In testing code, we could dump those model so that our model will know how we will see the evaluation of the model. You see this? You can see this. This is a model at H5. Now I will run this code so that you get a good idea how a model is working. This is our main code. Yeah, now our resume has opened. Now I'm going to load a face here. Ah, this is our data set. Now I'm loading a fifth person face here. Okay. And then I'm loading his ears. I have loaded his ears. And I'm going to load his walking style. Like, and yeah, now I'm going to predict. Yeah, here you can see that the human identification successfully matched. Here, these three are depends on one person, depend to one person. So here, our training model proved that our human identification is successfully matched. Yeah, thank you for watching our video. For more video, follow our YouTube channel. Please like, share, and subscribe. Thank you.